Okay, sorry, slow intro, but I'm recording this on Friday, so I'm happy. It's Friday, end of the week. I think you guys are going to be watching this when it's Monday. Sorry. So this lesson is going to encompass slope-intercept form, point-slope form, and parallel and perpendicular lines. A review from Algebra 1, but still it's something just to kind of keep fresh in our minds, especially going forward, some future material, okay? So we're going to go ahead and talk about both forms and then what is parallel and perpendicular lines when it comes to the graphs of them and their slopes, okay? So the first definition, slope-intercept form, I don't know if we call it definition, but the first concept, I guess it's a better word for it, okay? This is something that got drilled into you a lot repeatedly, and the reason why this is drilled into your head is because it's the easiest way to graph something, okay? So, to make it even more simpler than what this is saying, okay, B is like your starting point, in a way. You know, where on the graph am I going to start at? And it's somewhere here, somewhere along the y-axis, okay? This right here, which is your slope, okay, tells you the change, okay, the change that's occurring between each point, okay, from the starting point, okay? That's why we use it. It's very straightforward, okay? So if I start here at 1 and my slope's 2, I'm going to go up, up 2 over 1, up 2 over 1. If I go in the other direction, it'd be down 2 over 1, okay? So slope-intercept form, very common, and for a good reason, okay? So if I had this right here, and I wanted you to write the equation of this kind of slope-intercept form, how would you do it? Well, here's the deal. If we look at the line itself, okay, and I guess we should state the starting point, I believe I said this already in the video, but it's the y-intercept, okay? So look at the y-intercept of this graph. Can you see it? Yeah. Can you estimate it? Probably. Do you want to estimate? No. All right. Not the greatest idea. So what are we going to do? Well, here's the thing. To write it in this format, I need two things. I need a slope and a y-intercept. Okay? Once I have those, I can write the equation. So let's just find the slope first. Okay? So I'm going to write the points up here. Slope is rise over run. Okay? Another way was, you remember, delta y over delta x, changes of things. Okay? So the changes in y's would be 3 minus 4 up top, and then 2 minus a negative 1 on the bottom. A lot of times people ask, well, Mr. McCullough, does it matter? Could I do 4 minus 3 and then negative 1 minus 2 on the bottom? Absolutely. Okay? But whatever you pick, stick with it. Don't go in this direction for the x's and then this direction for the y's. You don't want to flip-flop them. Okay? Because then you really are not looking at those 2 points anymore because you're looking at 2 different coordinates in a way when you're finding the changes. So on top, we get negative 1. On the bottom, we get what? 3. Okay, so negative a third. And look at the graph. Does it match it? Yeah. So it should be a negative slope graph. Okay, so that's good. That gives us some reassurance we're on the right path. So I got this guy. Now the y-intercept. I don't want to guess. So how can I do this? Well, this equation is for the entire line. If I plug a point in here, any xy point, along with the slope, I can solve what's left, which is the y-intercept. It's almost like working backwards in a way to figure out what the equation will be. Okay? So let's do that. So it's your choice. So your choice, pick one point. Okay? Let's do that. I don't know about you, but 2, 3 sounds good. Only reason why I picked it is it doesn't have a negative sign, and negatives can be a little bit difficult if you're not paying attention, okay? So let's use that. So my x value is 2 and my y value is 3. So let's plug it into this. So it'd be 3 equals, my slope is negative a third times 2 plus b. Okay? Multiply. And then last step, add 2/3 to both sides to get b by itself. Remember, b is the y-intercept. Okay? So 3 plus 2/3, you can leave it 3. You can leave it as 3 2/3, or do it as an improper fraction. Either way, I tend to go for the improper fraction kind. So we'll write this separately real quick. Common denominator would be 3. So this would be what, 9/3, right? So that'd be 11/3 when I add them. So there's my y-intercept for that guy. Now we put everything together. So y equals, negative 1/3 x plus 11/3. That's my final answer. Or 3 2/3. It's a good thing we didn't estimate it, because 3 2/3, 1, 2, 3. If I broke this up into thirds, maybe I can get to that conclusion, but you don't want to really estimate in a way. We could estimate to see if our answer is going to work out correctly, and it does. It really does. Okay? Not too bad, right? Remember, these points work for the line, so that's why it doesn't matter what we pick. Okay, I'm going to pick this set of points. I'm going to get the same solutions. Okay? I'm going to get the same y-intercept. It's not like it's a point on a different line. Try one more. This one's actually a little bit simpler. And pause the video and try it out yourself. Okay? So write the equation slope-intercept form. Now I give you the 2 points. You see the y-intercept in this case? I know what it is for sure. It's going to be what? 1, 2, 3. It's 3. Oh, bother. Okay, they're all got 3s. Okay, I can't eliminate an answer. No, that sucks. Now we try another one. Okay, slope-wise, look at the line. Is it positive or negative? It's negative, right? So it looks like we're down to these two now. Those two options. And I apologize. This A is this guy, B, C, and D. It's not stretched out right. Well, slope, we go, what, down 1, 2, over 1, 2, 3, 4, 5, 6. The slope looks like it's 2/6, which reduces to 1/3. So that's our final answer, negative 1/3 x plus 3. And we're done. Now, could you do this process? Absolutely. Okay, that's no problem. In fact, why not? It's good practice. Let's do that. So let's see, my 2 points were what did I say? 0, 3, 1, 2, 3, 4, 5, 6. 6, 1. So we know what the answer is. We saw it visually. It wasn't difficult, but can we do the algebra that supports it? I hope we can. 0 is a great number to work with, too. So on top, I'll do 1 minus 3. On the bottom, 6 minus 0. Remember, you can flip the numbers for both of them. Don't just flip one and not the other. You get negative 2 over 6, negative 1/3. Hey, that's what we got here. We're on the right track. Now, we pick a point because we need to figure out where does this graph start? Where's the y-intercept at? Okay? So let's do that. We're going to pick this guy because 0 is easy to work with. So 3, which is the y value here, right? I'll substitute that, equals negative 1/3 times my x value plus b. I think this is going to work. 3 equals b when I'm finished. Put it together, negative 1/3 x plus 3. Okay? Not bad. Definitely good to know the algebra side, because if you can't really pinpoint where the y-intercept is, it's going to be a little bit difficult. Okay, next one, point slope form. Okay, so another equation that I want you to write down here. Okay, these are the coordinates of the points that you're looking at. Here's the slope. And when do you use this one or when do you use this guy? Honestly, it becomes a preference. It's what information you have. To use this guy, the information you need is in the title. You need a point, you need a slope to do this. Once you have that, you can rearrange everything, and you're going to get your equation in the end. Okay? Here, it's kind of like the same thing, but I have to piece together the two parts that I figured out into one. When you rearrange this guy, you're going to get your answer right off the bat. Okay? So probably a little quicker, to be honest. All right? Where's this guy come from? Is this equation just made up? No. Think of it this way. If that's what my slope is, and the subscripts are just there to name the points, if I multiply both sides by the x sub 2 minus x sub 1, those cancel. And look what I got. And I'll flip this. I apologize. Does not look like point slope form. Okay? So it does come from somewhere. That's just a random thing. Okay, let's try two problems out. And we'll talk about parallel and perpendicular. Write the equation in slope-intercept form for the line that has a slope of -3/5 and passes through 5, -2. Now, you might say, well, wait a minute, Mr. McCall, I thought we were using point slope form. Why are we writing it in this format? We're using point slope form to get to this guy, all right? So it's like for one equation to the next is what we're actually going to do. So for the first part, we have a slope of -3/5, and we have a point of 5, -2, okay? So I'll write the equation over here so we have a reference to it, okay? So the y sub 1 and the x sub 1, okay? Those two values in particular is what comes from the point that you select, okay? This is x sub 1, this is y sub 1. Now, this and this guy right here, okay? The two variables. Now, they stay the way they are. Okay, you don't plug nothing into them. We only need 1 point, that's it. Okay? So let's go ahead and substitute our values in. So it'd be y minus a -2, that's what this guy is, equals, the slope is -3/5, x minus 5. There's my substitution step. Okay, let's clean it up. So this is a plus sign because we're subtracting a negative. Over here, I'm going to distribute a little bit. So -3/5 x. Now here, we could reduce at the same time, okay? 3/5, -3/5 times -5. Negatives make it a positive, right? 3 times 5 is 15. 15 divided by 3 gives me 3. I think a lot of times people get scared with the fraction, but sometimes the fractions work out nicely. Okay? Now, this isn't in y equals mx plus b format yet. We got one final step, and that's to get y by itself. So subtract 2 to both sides. We get y equals -3/5 x plus 1. Okay? And there's my line. Okay? Any questions? No? Okay. I'm assuming you understand that. So, and well, can we check to see if that does work? Yeah. If you were to graph this, you can use Desmos. That's fine. If you graph this on Desmos, locate the point 5, -2. Does it cross the line? And it should. And then use the slope to see if the other points that you locate are on that line too. So graphing this is a great way to check your work. Okay, let's do another one. I got some space down here. So they tell me the slope is 2/3, and the point I'm going to use is -3, -1. I encourage you to pause the video, try it yourself. So I'm going to use this equation up here to figure it out. The This is my x sub 1 and y sub 1. Some people like labeling just to help them. That's fine. Okay, so we got y minus, this is y sub 1, negative 1. Always be careful of the negatives. I put parentheses there. It just kind of helps me remember that. Equals 2/3 x minus a negative 3. Okay. Now let's clean it up. So this will be y plus 1. Okay, over here, negatives make it a positive, right? This is a positive 3, so I'm going to put positive there. There we go. 2/3 times x is 2/3 x. 2/3 times 3, well, that's what? 2 times 3 is 6. Divided by 3 is 2. Last step, subtract 1 to both sides. So 2/3 x plus 1. That's my final answer. So let's see, which one is that? It'd be A. A's the guy. Okay? Not too bad, right? Do you see the advantage of this type of form? See how I didn't have to piece anything together at the end like the other format? It just kind of, once you rearrange it, it's already in its final format. The other one, you have to piece together the slope and the y-intercept you figured out and then put them together in one format. Honestly, is it that big of a deal with that extra step? No, it isn't. Okay. Now, do we got time to do this? Oh, I always want to keep the videos small enough. Why not? You know what? What the heck? It's Friday. We're having fun, right? You having fun along with me? I hope so. I hope so. Okay, one more for the road. I give you 2 points. Come up with the equation for the line. Okay. They don't tell me what to do, right? I could use either format to figure this out. To be honest with you, it becomes a preference. It doesn't really matter. So, I don't know. I wish I could do a vote at home thing. You at home, vote now so you can tell me which format to use. Slope intercept or point slope? And why not? You know what? We'll use point slope form. We're going to use this guy. No particular reason, just randomly. So I need 2 things. I need a slope and a point. So I don't know the slope, right? I need to figure that out first. So I'm going to go ahead and use those points. So I'm going to say 7 minus a negative 3 divided by negative 3 minus 2. Okay? So this becomes a positive, so this would be a 10 on top. On the bottom, we'd get what? Negative 5. If I divide those, I get negative 2. Okay, the slope's good. Now I get to pick a point. Just like this guy. Remember how we picked a point for this guy? Now I get to pick one for this. And, there's negatives no matter what. That's a bummer. Well, let's do 2. Let's do 2 negative 3. Yeah, why not? So, I pick point 2 negative 3. Okay? So this is my x sub 1. This is my y sub 1. So here we go. I'm going to have y minus a negative 3 equals negative 2 times x minus 2. Okay? Clean this up. This will be a plus 3. Over here, I get negative 2x plus 4. That's after I distribute the negative 2. Okay? Last step, subtract 3 to the other side. So negative 2x plus 1. Okay, so that would be what? The last option here? Option D? Yeah, I got shifted. But option D. Okay? If I found the slope and put this point into here, I'd find the answer to be 1, and then I have to put them both together. Okay? So when you see problems like this, do what's comfortable to you. Okay? You know what some people will probably do? They'll graph it. Which graphing's fine. You can graph it and just use the slope to figure out where the y-intercept is, and you're done. So there's a lot of ways of coming up with this. Okay. Last concept, parallel and perpendicular. This should look familiar from Algebra 1 and geometry, hopefully. Parallel lines mean that they don't intersect. If the lines don't intersect, then they must have the same slope, right? Okay? If my line, like here's my grid, here's one line. If this other line is just slightly, just ever so slightly turning, like the slope isn't quite the same, it doesn't look like it's an issue here, but further along the path, they will cross. Okay? So to be parallel, they have to be the same slope in order for them to never intersect. Now, perpendicular. A lot of ways of showing something's perpendicular. In fact, in mathematics, I think there's way too many ways. And you can see stuff with matrices, you can see stuff with vectors, you can see stuff with slopes, which we'll do here. So let's talk about that. So to be perpendicular, the slopes have to be, and this is important, okay, if and only if the product of their slopes is -1, okay? Or, if you want to write this down, this is another way that teachers describe it. So, parallel, same slope, perpendicular, they also call it opposite reciprocal. Okay? The slopes are opposite reciprocals of each other. What does that mean? Well, the slope for line 1 is 5. The slope for the line that's perpendicular, line 2, would be -1/5. Okay? If I multiply 5 times -1/5, I get -1. That's what this says. That's good. Okay? Opposite means change the sign. If it's positive, make it negative, vice versa. Reciprocal means you're taking the number and you're literally going to flip it. Okay? So it's going to be 5/1 is 1/5. I could reverse it, right? Let's do this instead. The slope of my first line is -2/3. The slope of the line that's perpendicular would be a positive 3/2. If I multiply them, I do get the -1. Okay? So parallel is easy, nothing's changing, but perpendicular, you're going to have to change some things. The sign of the slope, and you're also going to have to change the value itself, the reciprocal of it. Okay? So that's what perpendicular is. We could confirm with a lot of different methods. Just for the sake of this video, we're going to keep it short. I don't know, maybe later on I'll put a video up there as to why it's like that. Okay? So here we go. And I'm going to box this like that so we can do the problems. Write the equation in slope-intercept form for a line that passes through that point and is perpendicular to this line. Okay? So no matter what, we're always in need of a slope and a point, no matter what. Okay? The slope's the easiest thing to think of. These lines are perpendicular to this guy. Okay? So what's the slope for this guy? Well, it's -5. So we just said if they're perpendicular, they're opposite reciprocals. So therefore, oh man, oh that was so close. Hey, how about that? If that was negative, it would work. But anyway, if it's opposite reciprocals, if we start out with -5, it's going to be a 1/5 slope. So the equation of the line that I'm coming up with that's perpendicular to this guy has a slope of 1/5. Okay. Do I got the slope? Yes. Now I need a point. Okay, that's not too bad. Sorry, I'm tired of holding that. We got 3, -2. Okay, so there it is. Now come up with the equation. All right. This isn't too bad, to be honest. What do I want to do? Point slope form or slope intercept? Well, I'll tell you what. We did point slope form 3 times, I think. Why don't we use slope intercept form? Yeah. Let's use this. We'll do the other one later, the next example. Okay? So this is my x coordinate, my y coordinate. So I'm going to plug all of this information, I'm going to plug into here so I can find my y-intercept. And then I'll put it all together. Okay? Because I almost have all the information here. I just don't have the y-intercept. So -2 equals 1/5 times 3 plus b. Okay? So -2 is 3/5. Oops. Plus b. Subtract the 3/5 the other side. I'll put that over 1. I'll combine the fractions here. I don't know why I don't like mixed numbers. I think it's just because I was always taught with improper fractions all the time. So 5 can go to make this guy a common denominator of 5, so that's -10. So this would be -13 over 5. That's b. Okay. So we have the slope, we have the y-intercept, put them together. So it'd be 1/5 x minus 13/5. That's my final answer. Okay. And making a comparison, yeah, it's 1 extra step than the other guy. I guess. Technically, maybe not, but you just got to remember your final answer, you got to combine them. Okay? All right. Moving on. We're doing pretty good so far, I think, with time. This is our last problem. Okay? So, write the equation of a line that passes through 3/5, almost said 3/5, and it's perpendicular to the falling line. Man, I did 2 perpendicular problems. Wonder why I did that. No, I don't remember. I do not remember. Okay. So, I got a point, 3/5. Let's talk about the slope. So this line that I'm trying to create is perpendicular to this guy, and its slope is 3. So I need to find the opposite reciprocal of 3. Opposite would be negative. Reciprocal would be to flip it. So 1/3. Teachers hate when you say the word flip. Just caution. It's just because you're not using the right vocabulary. Flip can be interpreted in many different ways. So reciprocal is more specific. Okay? So I want to keep that in mind. Just don't say to a teacher or just to any math person, oh, you flip it, okay? Use the right word, okay? Make sure you use reciprocal. Okay, I'm going to use this guy now. No reason, I just figured, let's have a variety here, right? So to do this is my x1, y1. Okay, now we're going to substitute. So y minus 5 equals -1/3 and then x minus 3. There's my substitution step. Okay. Next up, simplify. So y minus 5 equals -1/3 x, and negative makes this guy positive. Hey, 1/3 and 3. What do we get? 1. This is really nice. Last step, add 5 to the other side. So -1/3 x plus 6. That's my final answer. So option B. Okay, option B. Now what you could do, graph them. Graph both of those lines. They should intersect. They should form a right angle because they're perpendicular. If I multiply these two together, I get -1 as the product, which is what perpendicular lines do, their slopes. So it kind of all fits nicely together. Okay? So I don't know, stay tuned. Maybe I'll do a small reason as to why they're opposite reciprocals. That'd be kind of a cool video to do. But other than that, that's it, guys. So hope you're doing well. This is the last part. Look over the notes, okay? And see if you have any questions. Feel free to contact me. Until then, I'll see you all in the next video.